Hey there, welcome to the video discussing section 5.5 on the trapezoidal rule. So we finished off chapter 5 with no look at finding areas on the curve. We've used LRAM, RM, MRAM, which of course are rectangles. And of course we've done the definite integral, which does get us the true or accurate area. But there's another approximation method we haven't discussed yet called the trapezoidal rule, which does provide a better estimate than LRAM, RM, or MRAM when compared to the definite integral. So first off, let's review the formula for area of a trapezoid. So it's right here, 1/2 times B1 plus B2 times H, where B1 and B2 are the bases and the parallel bases, right? And H is the altitude or the separation between the two bases, or the two parallel sides, if you want to think of it that way. So now how does this apply to find the area between the curve and the x-axis? So if you kind of tilt your head either 90 degrees clockwise or counterclockwise, and if you say we focus on this figure right there, which looks like that, if I simply rotate it, in this case I'm rotating it 90 degrees counterclockwise, and this right here is delta x, this right here we call like y1, this right here we call y2. So apparently your height is like delta x, and your bases are like y1, y2, because the y coordinate at these points on the curve here will represent the height, or I guess the length of each of those two sides of the trapezoid, which will actually be the bases. So it's kind of a reverse way of thinking about it, whereas your delta x is actually more like the height, h is like delta x, your B1 and B2 are like Y1 and Y2. So that's how we're going to kind of look at this. But your height again is like delta x, which is basically going to be minus a over n, because we have n subintervals. And we are going to partition this in equal lengths right now, but then we'll talk about when they're not equal subinterval lengths. So if I try to find the area of this region of f of x from a to b, if you think about it, you're doing 1/2 of y0 plus y1, those are the two lengths of your bases, times delta x, plus 1/2, do it again, y1 plus y2 times delta x. If you kind of keep going until you finish it off, 1/2 yn minus 1 plus yn times delta x. That will actually get us an estimate of the definite integral from a to b for f of x times dx. Now, in order to consolidate all this, so we can kind of recognize that a y1 is happening twice here, y2 also happens twice, but y0 and yn only happen once. The trapezoidal rule can be expressed more succinctly like that, where your height, or delta x, is b minus a over n. And interestingly, if you were to average LRAM and RRAM, you would get the same thing. For LRAM, starts with the leftmost coordinate, you use y0, y1, and you end at yn minus 1. Whereas RRAM, you skip y0, so you start at y1, the second y coordinate, and end at yn. So it's almost like you're averaging the LRAM and RRAM areas to get the trapezoidal rule. And this is under assumption that we're doing equal subinterval lengths. So let's apply it to example 1 here. We're integrating from 1 to 2. N equals 4 is an equal subinterval length. So for part A, I'm going to do my area. So it's going to be 2 minus 1 over 4. So each subinterval is 1/4. That's like your delta x. And your y0 is right there. So if you plug in 1, you should get 1. And then 2 times 1.25 squared plus 2 times 1.5 squared plus 2 times 1.75 squared, and then plus 4. Because when you plug 2 in, you do get the y coordinate 4. So that's 2 comma 4 here, plus 1 comma 1. But remember, that's 1.25, 1.5, and 1.75. Plug it into the form of x squared. So if you work all that out, I mean, it's really kind of wacky situation here. And actually, I can grab my calculator. You may want to do the same to make sure you get the same thing. 1.25 squared times 2 plus 1.5 squared times 2 plus 1.75 squared times 2, and then plus 5. So I think this inside part is 18.75. Divide by 4, you get 4.6875. Well, the true area, and what we're going to do is we're going to see whether we're going to have under overestimate. Or because this is concave up, if you think about the shape here, it's almost like these are going to be overestimated. It's kind of hard to tell. When you're concave down and you do a trapezoidal sum, that's going to be an underestimate. But when you do a trapezoidal rule with concave up, it's actually going to be an overestimate. And we can actually compare it. You could use the numerical integration calculator, or I hope you recognize the answer is x cubed over 3. You get 8/3 minus 1/3, which of course is 7/3. And I wonder what I did wrong here. Something seems a little bit off here. Not sure why we are off, because the integral should be x cubed over 3. So 8/3 minus. This is good. I'm making a mistake. Let me make sure I found the other one correctly. The trapezoidal rule. Yeah, something seems a little bit off here. Let's actually look at the completed notes. See what I did wrong. Oh, well, there you go. This is why it's always good to don't check your work. It's also 1/2 times all that, right? So it's 1/2 times your height times b1 plus b2. I was using the wrong formula, so I forgot to multiply by 1/2. So let's do 4.6875 divided by 2. Okay, 2.34375. My apologies about that. 7/3 is 2.33. So yes, we do get an overestimate. So make sure you're using the right formula. Okay, moving right along. Now sometimes your spacings might be different. So you will not use the trapezoidal rule. Instead, you use something called trapezoidal sum. So there's actually a difference between the rule and the sum. The rule is just, hey, it's all the same intervals. The sum is when they're not the same intervals, or it's an approximation. So let's do a trapezoidal sum for this bad boy here. So that's at 0. That's 8. That's 14. That's 22. That's 24. This is x. That's y. And they kind of look like this. They apparently got two right triangles on the left and right sides here. But you follow the same kind of situation. 1/2 0 plus 7 times 8. So remember, this is your b1, that's b2, and this is the height of each trapezoid. But of course, it's a right triangle, so that's what you get. Then 1/2 7 plus 8 times the spacing there, which is 6, plus 1/2 times 8 plus 2, times that spacing, which is 8, plus 1/2, the y value of 2 is 0, and that spacing, which is 2. And this will help you to get the area that we're looking for. And if you think about what we're trying to find here, we're actually trying to find the area of the cross section here in square feet, because we're basically multiplying feet by feet. Distance along the river's edge, and of course, the depth of water. So if you work it out, you should get 28. 3 times 15, that's 45. 4, that's 40. Still check my math here. And I think you get 7115 square feet. It's always good to kind of check the old notes, just to be sure. Actually, we had a different problem, or whatever it is. I guess on the AP, you don't really have to simplify if they don't ask you to. So, but there we go for that one. Okay. And so this problem, we really had two trapezoids, two triangles. Keep that in mind. But go through the process. And you can leave your answer unsimplified, like this here. But make sure you don't forget the units, or you can do feet squared. Okay. We'll do one more problem. Even if you have equal spacings, it's still good to kind of just follow this technique we talked about and compute each one separately. So in this case here, we're going to plug in 6. And remember, G prime is just going to be f of just plain old f. G del prime is f prime. So you plug 6 in, we're just finding the area. And we're starting at 0. So wherever that is. But let's actually skip over these 3 questions for now and kind of just look more at part D. We're doing a trapezoidal approximation from 3 to 15 using 6 subintervals. So you're going to do f of 3 plus 2 times f of 6. Actually, 15 minus 3 divided by 6, or 6, which is 2. So take that back. So if I erase this, so I'll just cross it off. Now, if we erase it, so what you're doing is you're doing 1/2 times f of 3 plus 2 times f of 5 plus 2 times f of 7 plus 2 times f of 9 plus 2 times f of 11 plus 2 times f of 13 plus f of 15. And your subintervals will be of width of 2, and that will be your answer. And your delta t should be actually 2 to 6 subintervals.